can't believe it's been 3 years since I started this project, and really the end is nowhere in sight. Several years back I was doing a lot of competition shooting and reloading for that, so I was reloading 45 and 9mm. I got this idea that it'd probably be better if I sorted out my brass by headstamp so I could get better, more consistent velocity and maybe better accuracy out of it. Sorting brass by headstamp is pretty slow work, and there were no neighborhood kids to exploit for this task. So I said to myself, you need to build a machine to do this for you. And so that's what led me to where we are today. The first version of this was quite a bit different. So I kind of want to take you through the evolution of this project and look at the design choices that were made along the way. The first version of this machine was very crude and very fast. And in fact, this is all that I have left of it. At this point, I've salvaged different parts for different things, but it was a binary sort operation. So really, the brass you wanted went one way and everything else went the other. It was very fast, but not very accurate, had all kinds of malfunction problems, just wasn't very reliable. The best, I think, accuracy-wise I was able to achieve was maybe 85 or 90% recognition, which is good, I mean, but it's not what I was looking for. After finishing this, I decided, it'd be really nice if I could have more slots to sort into. And so that kind of led to the next version of the project, which was quite a beast. Ugh. This guy. And the idea behind this was that you could put buckets around it and it can rotate freely and knock brass into the correct bucket. It's a pretty complex idea, has a lot of moving parts, elements, and overall had the same design problems that the previous idea had, in that you had brass falling down a long tube onto a glass lens with a camera underneath it. So eventually the lens would get scratched, cracked, broken, and it was just problematic. It wasn't very reliable. I couldn't get consistent pictures. Sometimes you can see a little wobble maybe in this, but even then the brass would fall just slightly off center. And so my pictures weren't centered. And that messes with the recognition a bit. This was a fun project in that it presented some interesting challenges, but took a long time. I think I spent the whole year 2020 tinkering and playing with this design. I think I released the video towards the end of the year in 2020. Of course, we were on lockdown and nothing else to do, right? So I took a break for a while, and because of COVID, I wasn't doing much competition shooting, if any. I started doing more rifle shooting and a lot more reloading around that. And I got an idea that I wanted to build an automated annealer. And so you can watch that video here. But out of that project, the annealing project, came this idea of a rotary plate or rotary table design. And after finishing that project, I'd achieved one of the things that I was trying to do here, which was very reliable consistency, being able to run many rounds through a system without jams or issues. The other thing was that it could do pistol and rifle brass. Not that you really need to anneal pistol brass, but the design lent itself to be used across multiple cartridges sizes. So that was another thing I was looking for. So I started down this path of how do I create a rotary version or a spinning rotary table version of the machine learning. I took a break and was thinking about it over that time, and the idea came to me that if I made it 3D printable, then lots of other people could build the same thing. So I started down that path, and this was version 3 of the project. There's some video of this thing in operation, but it's not great. It had issues. It was slow. One of the things I didn't realize is how much the brass shakes as the table spins, and so that shaking created vibrations, and you had to wait for that cartridge to stop vibrating or You know, if you spin a can, it will kind of, there's an effect, I'm not sure what it's called, but it's like a hula hoop sort of thing. And you have to wait for it to stop so you can get a clear picture. And so that slows everything down. And then alignment really mattered. This thing had to precisely stop the cartridge over the camera every single time. And that meant the holes in the plate had to be very close to the size of the brass. Otherwise, there would be gaps and the brass would be lined up differently with the camera. So this design, I wanted to make it work. I spent a lot of time on it, but unfortunately, this wasn't going to be the design I went with. So the next few designs were 3D printing designs. And I was trying to address the issues of speed. This first, I think this was version 4 of the sorter. I never really fully made this one work. But the idea was that you would use a single linear solenoid. You would drop, you know, the brass straight down there. You would have a lens underneath it, underneath the wedge. And you can take a picture of it. And then the solenoid would push the brass into the hole. I had all sorts of problems with this, and after this one, I kind of gave up on solenoids. They're just too problematic. They didn't have the power that you need, and to get one that did, it was very expensive. You're talking $60 to $100 for a single solenoid, and I just thought there's probably better ideas than this one. So this was the very simple version of that. This next design is very similar to what I ended up building and going with. This has some neat features. So it starts with the rotating disc that would be connected. I don't know where I lost the connector, but the rotating disc connects with an arm to like a piston. And brass would feed down the top and be pushed into a stopper. So you'd have something like this. And then as it goes back, it kind of pushes that piece out and grabs another one. So that was kind of the idea there. Not sure how well you can see that. It was a pretty cool idea, but what I realized was the problem, you get good centering here, but the problem again is compatibility with other cases, the camera issue, and I just, in doing this, came up with a better idea. So I never really finished this. I might return to something like this, some hybrid between this and what I currently have built. And I really like this idea. It just wasn't the one I ended up going with. I'm going to take this machine apart now and we can have a look at how everything works. Before we do that, let's just go over the basics. So we have a case feeder here, that's Dylan. I did have to bend a tube because I just didn't make my machine long enough. Oh well. So it feeds into the top, and then using that same rotating disc piston design, gets pushed in over a camera and then is dropped in to the sorter. So the camera talks to the computer, it gives it a signal as to what tray it belongs in and tells the sorter to move. And once it's done moving, it feeds another piece in, dropping that sorted piece into the tube, something like that. So I don't know if you can get a look at that. There's an arm in there. Of course, when you do it slow, it's not going to work. We feed a new piece of brass in, and then we kick it back. So I'm manually running that. Let's go ahead and take this feeding hood off, and you'll get a better idea of the mechanism. That's a feeding funnel, and I've printed different sizes for the different length of cartridge. So for a rifle cartridge, you'd have a much shorter funnel. You want the tip of the cartridge to be at the base of the funnel. So let's take this off. All right. Okay, let me position this better. So this will give you a better idea how it works. So this is spring loaded, and it captures the cartridge like a pinch. It pinches the cartridge in between it, and holds it over the camera. So there's no lens involved. The camera's got a straight, clear shot of the head stamp without involving a piece of glass. So this was the thing I'm most proud of, was coming up with this idea. I wasn't basing it off of anyone else's idea. It was kind of an original. And then the second thing is, as this comes back, this spring-loaded arm will knock the brass back out. Again, that was an original idea. I'm sure someone has done something like it, but as far as what I've seen, I'm the only one so far. So the brass on the backstroke will stop for a second, and then this will push it back through. Of course, when you do it slow, you don't have enough momentum, so it needs to have a little bit of speed. And that's the basics of it. There's one motor underneath, right here, which runs the wheel. You have the two feeder arms, and then the spring-loaded. You could probably get a better shot of that here. This is just a spring-loaded arm. And then on this side, I printed each of these parts as a 3D printed part, of course, but then I just used I printed a rod, and then instead of printing the threads, I just threaded it with a die. Seemed easier, and then put a couple nuts on there, and that allows me to determine where this stops, so it stops over the hole, or it doesn't go too far back. If it goes too far back, then this arm won't come in, so that arm has to have clearance to scrape the piece of brass off. So that was this piece, and then so this is really what I'm calling the feeder piece. There's a camera underneath, and I need to work on that a little bit. I need to clean it up. It still has some silly wiring there, but the camera is threaded in. Let's pull that out and have a look. Well, I better unplug it first. So it's a USB camera you can buy on Amazon for about 30 bucks. And there's no reason to have this long wiring hanging off. I just was lazy. So you can see I put a lock nut that lets me get to the same position, same camera position when I put it back in. There's a backlight mechanism, and I'll take this apart and show how that works, but it's really a spool design, and I'm wrapping some LED lighting around that spool and dropping it in. And then I needed to connect that up, so I just drilled a hole and put a couple wires in there, and then connected it into the camera module, which already has 5 volts. So I'll get rid of those wires at some point in the future and just have it direct connect to the LEDs, but this was working, and I was excited to get this video out. So from there, we have a single motor. We have this plate. I haven't named it, but it was octo sort, but now it has 10 holes, so you can come up with a name. I was originally I was going to 3D print this whole thing, but then I got to thinking that it would be much better to do something that was compatible with PVC, mainly because everyone can have access to PVC and you can add connectors. As you can see on here, if you had a big bucket of stuff you wanted to sort, you could connect the PVC to your different buckets. And so I thought this was going to be the most flexible. I used a heat gun and maybe got a little too hot in parts, but to bend the pipes the way I wanted them, because it was much cheaper than buying these guys at $1 or $2 a piece. And I was just really being cheap on it. So there's an arm here that rotates 360 degrees on a lock nut. And then on the tubing, I sized the hole so it was pretty tight fit for these, but where I also printed the ability to have a lock nut on those. And I think you can see that on this one. Well, it's really just a screw that locks it in place. So, and from there, there's a single motor underneath, and all that's fed into this mess. And what we're looking at here is the electronics for the Arduino side of things. This is sort of the middleman between the computer and the motors. There's two TB6600 controllers, an Arduino Uno with a shield on it, and then a 5-volt converter. We're feeding 10 volts in. There's a little power switch on the side. We're feeding 12 volts in. There's a power switch, and then we send 12 volts to the motors, but 5 volts to the rest of the electronics. And then for powering the whole thing, just using a very cheap power supply I got off of Amazon, a 12-volt power supply. Okay, the machine is back together. Well, let's talk a little bit about how we get it started. So I didn't install homing sensors yet. I will at some point, but it's so easy to do. I might not, I don't know. But really what I want to do is just align this to what I'm going to consider the 0 tray. And so everything beyond this is 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way around. So 0 is aligned. Then I want to put this into the forward feed position. You'll feel it's under spring pressure, but that's about where I want it. So once I have that set, I can go ahead and hit my power button down here. And you'll see as I hit that, this stuff kind of locks in place. I don't know if you could see it, but it does make a little bit of a jump. So now these are pretty tight. The magnets on the motor are holding them in place. And so the machine is now ready for sorting or training. Okay, let's have a look at the software and we'll talk about training. So right now I'm in the training tab, or the training UI, and we have a model, the 9mm, and it's not completely trained, so I want to take you through what that looks like. So first of all, we'll hit the feed button. And we see we got a head stamp that the menu here changed. If it wasn't federal, if it wasn't FC, we could select what it was and then we'd hit add image. In this case, it was selected. The other thing I'm going to do is I want to enable the use of rotations. This will allow us to add more images and get more training per cartridge. And you'll see how that works here in a second. So here we go. We have I can't even see what it is, but it does look like RP, and it did pick it up. So I do see the R and the P there. And you can see how we have, the camera has, or the image processing has actually centered the image and then rotated it, so we have multiple versions of that image. So we'll go ahead and hit add image and look at our next one. So in this case, we didn't get anything. So we got blank because I forgot to turn the feeder on. And here's an example of one which didn't get detected correctly. So we have spear, looks like plus P, and it detected it as Hornady. So we'll go ahead and change that to spear. I didn't create a plus P, but let's go ahead and let's actually create a spear plus P. So we'll go ahead and add that head stamp, and then we'll add the images. And let's get this. So FC, this one is correct. Spear. Blazer. And so what I'm looking at is I'm looking at the image here and then what is picked up here. So this should automatically change this each time I hit feed. And so this one is SIG and it picked it up as spear. So we'll go ahead and switch it to SIG and we'll add the images. Great. So you get the general idea here. Once you've done this a little bit, you can go ahead and save all that training. And this is going to go in and start programming, all the images that we've taken against all the images it already has and building that brain or that model. This can take some time, and the faster your computer is, the less time it will take. This laptop's pretty decent, so it shouldn't take very long, but it can take a couple minutes. Okay, we're back. Our model has completed its save and its training, and now we can either continue down the path of training more or we can run it. So let's go and look at the run menu. So this is a pretty simple interface. What we have is a listing of our slots from 0 to 9, 0 being a catch-all slot you can't configure, but each of these slots represents all the head stamps. In the menu, there's an item for every head stamp you've trained for this model. So I've pre-configured it. The ones that I don't want to send brass to will be marked as blank. So 7, 8, and 9. I have 3 holes in my feeder tray that I didn't put PVC pipe in. And so at this point, we're ready to start. So I'll go ahead and hit the start. Okay, if you heard that alarm, that's because we're out of brass and the machine has stopped. Well, that's pretty much all I got today. Like I said, I'm going to keep working on this, keep refining it, but I wanted to talk a little bit about my plans for this machine and the future. Hopefully in the next few weeks, it might take longer, life happens, but I would like to release all the 3D models, a parts list, and the software for install. I probably won't release the source code for the software. That's something I want to retain at this point. I might end up selling the software at some point in the future. I'm not quite sure, but I would like to see this project grow and really trying to gauge interest. So let me know in the comments if this is something you'd be interested in building or trying, and your thoughts, any ideas you might have. I'm willing to steal any ideas that you're willing to give. I guess I wouldn't be stealing, but I'll borrow any ideas you have that would improve this. This version, the 3D printed version, was really something I wanted to get out there for the community. I'm probably going to build one out of metal for myself, aluminum and steel, just because I like metal things. They're shinier. One more thing I wanted to give you all was a sort of price list or a cost list. And so just this machine, let's go through it real quick. So there's two NEMA 17 motors, about 20 bucks, two TB 6600 controllers, and again for both of them 20 bucks. I usually buy them in a 3 or 4 pack, so you can save money there. But if you only need two, only buy two. The Arduino Uno, $10, $15, $20, depending on the quality that you get. They're really generally the same. The true Arduino models are a little better. USB camera is a 100-degree wide-angle camera. It's about 30 bucks. And then you have little screws, and you saw that there's brass inserts and wiring. All that stuff can add up if you have to buy a ton of it, but you don't need much here. You could probably get all that stuff for, I probably have a few dollars worth of parts, but I already had it all. So maybe $20, $30 in hardware for the screws and the wires and stuff. And then the last thing you need is a computer, and that's the most expensive thing. If you already have one, installing the software right now works with Windows 10 and greater. I don't really have any plan on supporting Mac or Linux at this point. I kind of did this project for myself, and I'm willing to share it with others, but I'm not sure that I want to go into supporting other platforms, so I'll probably keep it for Windows. The nice thing about it is if you don't have a computer and you want to dedicate something for this type of project, you can get on eBay and buy, like an Optiplex, a Dell Optiplex for $100. It's going to work fine. You probably need a monitor and a mouse, but you can buy a laptop for a couple $100 on eBay. So it's available. And if you look at some of the other machines that are out there that people are selling that do something like this, I think there's a couple of them now in the market. They're asking a couple thousand for them. So, a few $100 for parts and a computer. It's not too bad. I think it's a reasonable thing. Anyhow, let me know what your thoughts are on this. Put them in the comments. I'm pretty good about responding to those. Have a great day, y'all.